right, we're going to go through and finish this last packet, packet 4. So this is talking about residual plots. So in the live session, we just went over how to calculate residuals again, just as a review. And now we're going to talk about residual plots. So a residual plot is a scatter plot that displays the residuals on a vertical axis and the explanatory variable on the horizontal axis. So residual plots help determine whether the regression model is appropriate. The regression model is a linear model, right? Regression line, think about that. Where are my stickies? Y hat equals b sub 0 plus b sub 1x. That's basically the statistics version of y equals mx plus b. When I graph y equals mx plus b, it's a straight line. So regression models are linear, at least the ones that we're talking about in this class. So we're wondering if a linear model is appropriate. A different type of model, a nonlinear model, might be more appropriate. And we'll be able to tell based on the residual plots. So if there is no leftover curved pattern in the residual plot, the regression model is appropriate. We want a random smattering of plots. We want this. This is what we want. This is what we want. Our model is appropriate if our residual plot looks like this. That means, because look, this is our model, right? This was our guess, this vertical line. If we have a residual of 0, which is the goal, right? Think about what residual means. Residual means how off was our model? Our actual y versus our predicted y. Did our model predict the actual amount well? And if our model was right in the middle of our predictions, we should have some of the residuals up here, some of the residuals down here, right? Our plot should be right in the middle, like our 0 line. This would be, if any dot landed on here, that means that our model worked perfectly, right? We have 0 residual because the actual was the predicted. All of these dots on top, if I have positive residuals, think about what that means. Actual minus predicted. That means our actual was larger than our predicted, so we underpredicted up here. Underpredicted. Because our residual is positive. All of these dots down here means we overpredicted. But we want our residual to be as close to 0 as possible, right? So each of these dots up top are under predictions because positive means that our actual was more than our predicted. That's how we would get a positive number. We would get a negative number if our predicted was bigger than our actual. All right, so if there's no leftover curve pattern, it looks random, then our regression model is appropriate. We like it. Our model is good. If there is a leftover curved pattern, consider using a regression model with a different form. So if we have a curved pattern in our residual plot, that means our linear model is not the best model for prediction. So looking at this residual plot comes from this graph right here. So if you look, the straight line is the prediction, right? This linear regression is the model that we use to make predictions of the data, and the scatter plots are the actual data. So you can see that there's data plots above the line and data plots below the line. Same here. So imagine if we just turn like this. All these actuals up top, where our actual was more than our predicted, all of these on the bottom are where our actual was less than our predicted, because that line, that highlighted line, is our prediction. So let's take a look at this dot right here. This dot has a residual of 1. That means our actual minus our predicted was 1. So we were 1 off, right? Alright, so let's take a look at different residual plots and see if we think that means the linear regression model that we have is appropriate or not appropriate. Remember, this is what we want. We don't want a curved pattern. Alright, A. Our residual plot, we're 0, and I'm going to highlight the 0 so you can see where it is. 0 would be a perfect prediction, because if we had a residual of 0, that means our actual and our predicted are exactly the same. All right, you'll notice a curved pattern, right? So does that mean that our regression model is appropriate or not appropriate? Not appropriate. All right, what about over here? There's our 0. Does this look like a random pattern that has random scatters all above the top and the bottom, or does it look like it's got a curving pattern? It's got a curving pattern. So if it's got a curving pattern, what does that mean? It means that our linear regression model is not appropriate. We should think about a nonlinear model to use for predicting our y values. So both of these are not appropriate. This curve is very apparent. This curve is not, but you can still see that we have up, 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 below, below, up, up. It's a curve.
Good afternoon, Banner.
What do we think about C? Does this residual plot tell us that the model is appropriate or not appropriate? All right, C is appropriate because it's actually pretty random. There's some spots up top and there's some data residuals on the bottom. It's relatively random. All right, what do we think about D? Appropriate or not appropriate? Our model is not appropriate. Look at this curve. It's a very apparent curve. We should not be using a linear model, a linear regression model, to make this prediction. Oh, and I forgot to highlight my zeros so you could see. Remember, a residual of 0 means that our model was perfect in predicting. All the residuals up top means we under-predicted because our actual is bigger than our prediction. And all these on the bottom means we over-predicted. All right, so what do we think about E? Highlight my 0. Do we think E shows that we have an appropriate linear regression model or not appropriate? All right, I hope you said appropriate. It looks pretty random to me. Was this right here an over prediction or an under prediction if I have a residual of 4.5? It was an under prediction. We have a positive residual, which would mean that our actual was larger than our predicted, so we under predicted. All right, what do we think about this? Appropriate or not appropriate? I hope you said not appropriate because you can see that curve that it's got going on. So when I say appropriate or not appropriate, I mean, is the regression model that we use to calculate our predictions, is that an appropriate use of modeling? All right, so interpreting residual plots. All right, so which graph shows the residual plot for the same data set? All right, remember the linear regression line is our predicted value of y. So looking at this, would this have a positive residual or a negative residual? It looks like our actual was bigger than our prediction, right? This is our prediction right here, and this is our actual. So this would have a positive residual because actual is larger than predicted, so a positive number, or I'm sorry, that would give me a positive residual because a bigger number minus a smaller number gives me a positive. All right. This one looks to be very close to right on the line. What about this one? Would this be a positive residual or a negative residual? Again, positive because our actual is larger. What about this one? Positive residual or negative? Negative, 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 negative. Do you see how they're all below the line? If I have a negative residual, that means that my prediction was small, my prediction was larger than my actual. My prediction is the line. My prediction was larger than my actual for all of these dots, so I'm going to have a negative residual. All right, so let's take a look at the residual plots over here and see which one matches that. So it looks like I had a positive residual one that's very close to 0, another positive, and then a bunch of negatives. So I start off here, I've got a positive residual here, got a negative here, so I can eliminate that because my first one is definitely positive, and then I've got another positive. Alright, my second point was pretty close to 0, so that's good there and there. And then it looks like, ooh, it's hard to see because they're coming up. Do you see how all of these are basically positive? They're all above the line. Whereas here, it goes down and then it goes back up. So which one of these two more reflects the points on this line? See how they're positive and they go down and then they become positive again? So C is my residual plot for this model. Alright. Example 4. The graph displays a residual plot that was constructed after running a least squared regression on a set of bivariate, which just means 2 variables, numerical data, quantitative data, right? What can you conclude from the graph? Alright. So my two options are, there appears to be a linear relationship between x and y, or there does not appear to be a linear relationship between x and y. Alright, I want you to go ahead and tell me which one you think, A or B. Alright, looking at this, it's definitely more of a curve. Do you see how I've got negative here and then positive here? So I have negative residuals here, and I have positive residuals here. I don't have random all over the place, right? So it ends up being more of a curve like mine was here because I have a group of positive, then a group of negative, then a group of positive. That is a sure sign, that curve, that my linear model is not appropriate. I need random residuals all over the place for my linear model to be appropriate. So B is my conclusion here. There does not appear to be a linear relationship because there's a curve in my residual plot. I want it to be random. I want there to be positive and negative throughout the residual plot. Alright, and then my last one, here's my practice AP problem having to do with residual plots. It says, which of the following scatter plots could have resulted in the above residual plot, and I put this residual plot off to the side. The y-axis scales are not the same in the scatter plots as the residuals. Okay. So looking at the, well, I'll go ahead and let you decide. Do you think it's A, B, C, or D? Okay. So this residual is obviously curved, right? So we know that a linear model is not appropriate. All right, we also know that we've got positive, then we've got negative, and then we've got another group of positive. So let's go ahead and draw our line of best fit for all of these. So let's see. Alright, a linear model is definitely appropriate for D, right? And we know based on our residual model that this would result in a perfect residual plot, so it can't be D. This would result in a random residual plot. Alright, so looking at this, which one of these results in positive, then negative, then positive? Well, here it looks like I have negative, positive, negative. Same here, I've got negative, positive, and negative. Up here I've got positive, negative, positive. So out of all these, it has to be A. And when I say positive or negative, I mean, is it above the prediction line, the linear regression line, or is it below? See, these 2 points are above, so I did positive. These would result in negative residuals. These would result in positive residuals. Remember, we said that actual minus predicted. If I have actual minus predicted and it's a positive number, that means this was bigger. if we have actual minus predicted and it's negative, that means my predicted was bigger. And my predicted is the line of best fit, and my actual are my dots, right? All right, so my actual and my dots, my predicted is my line. So my dot is bigger than my line, so that would result in a positive residual. My dot is smaller than my line, that would result in a negative residual. So that's where my plus and my minus come from. Plus, minus, plus, minus, plus, minus, minus, plus, minus. So it looks like my only possible answer is A.